Okay, so here we have problem number 2, week 8, chapter 13. We have square loop, where sides are given. It's made from the copper. The radius of the copper is given. So we have to find if the magnetic field perpendicular to the loop is changing at a rate 8.8 millitesla per second. What is magnitude of the current in the loop? The resistivity is given. Okay, so let's write down the given values first of all. So initially we have square loop does have many turns. No, doesn't give it. So the size of the is given. It is 6 centimeters. Everything has to be converted into SI unit. So D is given, and the radius is given of the wire, which is 1 millimeter. Again, it has to be an SI unit. It's made from the copper, so resistivity of the copper is given 1.7 times 10 to the power of minus 8. Also the rate, magnetic field, the rate is given, which is magnetic field divided by time, which is given in terms of 8.8 millitesla divided by second. Again, also has to be in SI unit. We have to find the current that is passing or circulating along this square loop. So how can we find it? So the first of all, we know that EMF itself is equal negative of number of turns dF over dt magnetic flux. Since the number of turns is only 1, we can leave it as a 1, and we can write it down minus dF over dt, or negative dBA over dt. Okay, or you can write it down A is constant, area of this loop, which is B, okay, which is d squared. So we end up with negative d squared, which is area, and dB over dt. Now dB over dt is given already, which is this one, 8.8 millitesla per second. Now when you substitute numbers, you should get the answer, and once you get it, you can leave it as it is, and then we know that the current is equal EMF over R. Okay, then the resistance, is it given, the resistance? No. So the resistance is equal rho L over area. Okay, if that's the case, then rho L divided area will be pi R squared. Okay, this is a cross section of this wire itself. And what about L? So how can we find the L? So the L is basically the total length of this wire. Okay, so that means L is equal 4 times of each D, which is 6 centimeter. Okay, again, centimeter has to be converted in the meter. Then that's it. Then you take the R, you plug it here, and you take EMF, you plug it here numbers, and you should get the answer. Of course, you cannot put a negative sign for the current, so always keep it as a positive sign for the current.